All right, so in this video, we're going to go through sample question number 22 from the Society of Actuaries ExamP list of sample questions. So the question reads, a health study tracked a group of persons for 5 years. At the beginning of the study, 20% were classified as heavy smokers, 30% were classified as light smokers, and 50% were classified as non-smokers. The results of the study showed that light smokers were twice as likely as non-smokers to die during the 5 years, but only half as likely to die as heavy smokers. A randomly selected participant from the study died during the 5-year period. Calculate the probability that a participant was a heavy smoker. All right, so first thing I like to do in any problem is let's see if we can visualize it with a picture, and let's list down our givens. First information it gives us is it's tracking smokers and also I guess non-smokers. But the probability, so if we randomly select somebody from the study, the probability that they are a heavy smoker, that's equal to 0.2. The probability that they're a light smoker, that's equal to 0.3. And the probability you're a non-smoker in this group is 0.5. And then it says, the results of the study showed that light smokers were twice as likely as non-smokers to die during the 5-year period. So this is kind of a conditional probability related to a different conditional probability. They're making kind of an algebraic expression. So these are kind of word problems you might have seen in 8th, 9th, 10th, 11th grade kind of stuff. So light smokers were twice as likely to die, so as non-smokers, right? So the probability of dying given you're a light smoker versus is equal to twice the probability of dying given you're a non-smoker. And then it says they were only half as likely to die versus heavy smokers, right? So the probability of dying given that you're a light smoker is equal to half the probability of dying given that you're a heavy smoker. And then some of you might have immediately done this without writing this. I just want to kind of be clear in why I'm automatically going to this. I'm just going to multiply 2 to both sides. So therefore the probability of dying given that, so it's 2 times the probability of dying given that you're a light smoker equals the probability of dying given that you're a heavy smoker. All right, and I have this information here. Okay, so I'm going to make a chart out of this. So this is the chart I like to make when given conditional probabilities, right? You might have noticed, again, seeing some of my other stuff, how it differs to charts I make when I'm given intersections versus, other charts I make, depending on what information I'm given. This is good for conditional probabilities. This column will be the probability of being in a specific group, right? So either you're heavy smoker, light smoker, non-smoker. I'm just going to say probability of, X or whatever, of being in that group. So you're either a heavy smoker, light smoker, or non-smoker. Then I'm going to say this is the probability that I'll make it the probability of so this would be the group that you're in. That's one thing. And this is the probability of actually being in that group. So 0.2 is the probability of being a heavy smoker in this group. 0.3 is the probability of being a light smoker. 0.5 is the probability of being a non-smoker. Now here, I'll put down the probability of dying given that you're in a specific group X. Okay? Now, we're not actually given concrete values. We're given values in relation to one another, right? So, and it's basically denoted by these algebraic expressions. So here, I can write these out as, let's just say the probability of dying given you're a non-smoker is equal to X. Therefore, the probability of dying, given that you're a light smoker, should be 2x. The probability of dying, given that you're a heavy smoker, should be 2 times the probability of dying given that you're a light smoker, which is 2x, so this would be 4x. So hopefully I made it super clear to see why I wrote out certain values the way I did. Now let's take a look at actually calculating what it's asking us. A participant from the study died. Calculate the probability that they were a heavy smoker. So the probability of being a heavy smoker given that someone died. That's equal to the probability of being a heavy smoker and dying over just the total probability of dying. So hopefully it's clear that this is a Bayes theorem problem. Kind of some telltale signs of being a Bayes theorem problem is we don't actually know these values, right? Another thing is they're asking us for the probability of being a heavy smoker given that we died, but the information we have is kind of the reverse. The probability that we died given that we're a heavy smoker. That kind of tells me we might be dealing with a Bayes theorem problem. Okay, so Bayes theorem, and again, I currently don't have a video on it. If you want me to make a video on it, just leave that down in the comments. But I don't have time to fully get into Bayes theorem. I just gotta say it's super important for you to know. So this is gonna be equal to the probability of dying given you're a heavy smoker times the probability of being a heavy smoker. Okay, and then in the denominator, it's the probability of dying given times the probability. The probability of dying given you're a heavy smoker times the probability of being a heavy smoker plus the probability of dying given you're a light smoker times the probability of being a light smoker plus the probability of dying given you're a non-smoker multiplied by the probability that you are a non-smoker. So filling this in, probability of dying given that you're a heavy smoker, that's 4x. Times the probability of being a heavy smoker, that's 0.2. And the reason I like making tables and diagrams and charts, I'm just pulling the values from this, right? I'm barely even thinking about this. And then my denominator is going to be 4x times 0.2 plus the probability of dying being a light smoker is 0.3 times the probability of dying given you're times the probability of being a light smoker, that's 2x. Dying given that you're a light smoker is 2x. Plus the probability of dying given that you're a non-smoker is simply just x times the probability of being a non-smoker, which is 0.5. Okay, now there's some simplification that can be done at this point. At this point, this is an algebraic problem. This is a value with a fraction. We have an x in every term. That cancels out. Easy. So now we're left with 4 times 0.2 over 4 times 0.2 plus 3 times 2, plus 0.3 times 2 plus 0.5. And I'm just going to put that into a calculator real quick. 4 times 0.2 all over 4 times 0.2 plus 0.3 times 2 plus 0.5. And that gets me a final answer of 0.42105. And then that continues onward. Right, so I guess this is approximately the answer. And the answer choices are rounded to 2 decimal places. So this is approximately 0.42, lining up with answer choice D. Okay, so let's see what the main takeaways from this problem are. Like the last few, actually, it's just straight up a Bayes theorem problem. So know the formula, super important, can't stress that enough. And kind of know how to use this chart, right? When you're given conditional probabilities, it's quite useful to make this chart in order to make your work a bit more efficient, right? First column, I just made it what are the different categories people can fall into? In this case, heavy smoker, light smoker, non-smoker. What is the probability of actually falling into that category, given you just randomly pick anyone from the entire group? 0.2, 0.3, 0.5. And then the conditional probability. Now, what are we talking about in this group? The probability of dying. So the probability of dying, given that you're a certain type of smoker, was this last column. And once I set up the equation for Bayes' theorem, that easily allowed me to just grab those values. Because I think that, for me, when starting out, it was a while ago since I took like my first probability theory course, but I think Bayes' theorem just seemed like it was a lot, just it seemed like I had to memorize a lot and figure out a lot, even though it's just calculating a single probability. This table makes things a lot easier, just so much easier. You might have also seen people use kind of a tree diagram to do Bayes' theorem. I used to do that. However, I think it's much longer and looks a lot more complicated. However, that's up to you. But other than that, that's all there is really to this question. Hopefully that helped you out. If it did, hit the like button, subscribe. That totally helps me out. And if there are any extra questions or anything you want me to clarify, leave that down in the comments. Other than that, good luck, guys.